In the last section, we spoke about some of the weird syntax right here. We're going to now have a very quick discussion and talk about why we had such a painful refactor to take our app over to a stateful widget. In other words, why did we have to create two separate classes right here? And why did our app widget have to have a createState method tied to it? Well, let's take a look at a diagram that's going to help us understand what's going on. Okay, so this is a flow diagram of what would happen if we did not have a stateful widget. That's the key, okay? So this is how life would be if we did not have stateful widgets. So let's walk through the flow here. At the very start, Flutter would decide to look at our app and render our widget on the screen of our device. Now we'll assume that our stateless widget of app right here, again this is considering the case we did not have a stateful widget, would create a new instance of our app widget. That app widget might have a counter variable assigned to it of 0. And so that new app widget would display the number 0 on the screen. So then maybe at some point in time, a user presses that button, and that increments the value of counter to 1. Now here's the key part. If Flutter then decided to re-render our application, it would create a new instance of our app widget. So we would now have two instances of the app class in play. We have the old copy that now has a counter value of 1 assigned to it, but Flutter, when it re-rendered our application, created a second instance of app, and that second instance has the initial value of counter assigned to it of 0. Flutter throws away the old copy of app, and it decides to now use the new one to represent our app widget on the screen of the device. And so when Flutter re-renders our application with this new copy of app, we still have the 0 value of counter. And so we still see 0 on the screen. Now the real key here, the key thing to understand, is why Flutter decides to create a new instance of our app widget. And the best way I can show you that is by pointing out the build method right here. So whenever Flutter tries to re-render our application, it's going to call the build method on every widget that we have inside of our application. When you look at this build method, you'll notice that every single widget that we create inside of here is created from scratch. So Material App right here is a new instance of the Material App class. This is a new instance of scaffold, a new instance of text, a new instance of floating action button. So every time that Flutter decides to re-render our application, it is creating a new instance of these widgets. So all the old instances get thrown away, and we create these new ones. And when we get this new instance of this widget, it comes with a completely reinitialized set of instance variables. So if we did not have stateful widgets, we would never see any changes appear on the screen of our device. Okay, so let's now talk about what's happening thanks to the fact that we do have stateful widgets. You know, what's happening now that we have these two separate classes? All right, so slightly different flow diagram here. So this is with stateful widgets. So we start off again with Flutter deciding to render our app on the screen of the device. It creates a new instance of the app widget. So here's the app widget right here. Like that's the top class, this one right here. When that widget is created, when the app widget is created, Flutter is then going to automatically call the createState method on that widget. So the createState method that you and I defined. So that's createState right here. Inside of createState, we create a new instance of appState and return it from that method. Flutter is going to take that appState object that we just created and it caches it. So it holds onto it and it does not throw it away. Then whenever a user presses that button, the counter will increment by 1. And because you and I called setState inside of our appState widget, Flutter decides to re-render our application. So at that point, a new instance of the app widget is created, just as it did before over on this diagram, but the old copy of appState is kept around. So we are not creating a new copy of appState, because that appState object gets cached and it sits around no matter how many times Flutter decides to re-render our application. Because appState does not get re-rendered, or excuse me, because appState does not get recreated, its instance variables do not get reset, or they don't get initialized back to their starting values. So we then re-render our app widget, but it uses this original copy of app state where the counter value is still set to 1. I think another diagram that might be helpful to take a quick glance at is this one right here. So here's our widget tree again. At the very top, we've got that app widget. So that's the original one right here, the first class we put together. And anytime the app is first created, we produce a new instance of app state through the createState method. So this widget right here, that first class that we put together, this thing is going to be thrown away, recreated many times in the lifecycle of our application. But the app state object over here only created one time. And then we hold on to it for as long as our app is running or until we decide that we don't want to render this widget on the screen anymore. Okay, so hopefully that gives you a better idea of why we have to create two classes right here. It's all because whenever Flutter decides to re-render our application, it's going to throw away this widget and it's going to try to recreate it. If we recreated it, then we would lose all the data that we had tied to that widget previously. So by making sure that we have this createState method right here, along with a separate app state class, we're going to hold on to our instance of the app state that is created no matter how many times our application is re-rendered. All right, so I think we got a better idea of what's going on here. So let's take a quick pause and we'll continue in the next section.